We will do paper 2 at the last.
This is paper 4, classified block 1.
Paper 6.
Paper 6 we will do as well. First discussion I will discuss. Figure 1.2 motion is there. Figure 1.2, the question is related. The question is related to the motion of an object. Figure 1.1 is a speed time graph for an ice skater. Okay. So this is a speed time graph. What is meant by deceleration? How we define the term deceleration? What is the definition of deceleration?
Reduction in speed.
Reduction in speed or decrease in speed or negative acceleration. But the what is meant by deceleration? The best is it is a decrease in speed in unit time.
Velocity every second. Velocity is not speed. Velocity.
A decrease in velocity
Every second.
in unit time. Every second, every second, or I can say unit time. That's the same thing.
We can say minute 2, right?
What?
We can say minute 2 instead of
We can say?
minute or hour or second.
Yeah, unit time means like it can be per second, per minute, per hour. Use of figure 1.1, determine the distance from 3 to 6. How to determine, if we have a speed time graph, how to determine the distance traveled? So speed time, area under the graph. So this is 3. From 3 to 6, we have to determine the distance. So what we have to do, we have to take area under the graph. So what is the total area under the graph? What is the shape? It is making a triangle and a rectangle. So area of the triangle, what's the area of the triangle? Half. Base, what about
base multiplied by height?
what about the base? It starts from 3 and ending at 6. So what is the base? 3. What about the height?
5 to.
It is starting from 5 and ending at 11. So it's 6.
So it's.
So it will be?
9. So just yes, 9.
Yeah, it is 9.
No, I don't.
Yeah, 9. No, I'm saying not the total for this one.
Yeah.
Now, what about the rectangle?
3 into 5 is equal to
Length into
15.
width. So this is 3 and the height is 5, which is 15.
15.
So what is the
that's
total
24.
distance traveled? The total distance traveled is area under the graph. So 9 meters and 15 meters. So 9 plus 15. What we got? We got 24 meters. That's the total distance which this object will cover.
Yes.
For students, those who join this week, you may not be able to understand this part, but we will discuss, inshallah, in the Thursday session.
Means you decided, sir.
Inshallah, I said. Deceleration between the time 3 seconds to 6 seconds. How we work out the deceleration from 3 seconds to 6 seconds? So we have to.
X1 minus X2 divided by 1 minus. Oh.
So if we need the deceleration, what is the speed here?
11.
What is the speed when time was 6?
5.
5. So what is acceleration or deceleration? The change.
7 minus 5 divided by 3 minus 6.
So which is 3.
Yeah,
So what is that will be 6 divided by 3? I'll get 2 meters per second square.
Sir, say good, please.
Good.
Thanks.
So it start with 11 and ending at 5. So the change in the speed was 6 and the time interval start from 3 and ending at 6. So the time interval was 3. So 6 divided by 3, that's equal to 2 meters per second square. What happened to the size of deceleration? Look, the acceleration and deceleration, it depends on the slope. The question is what happened to the size of the deceleration
Decreases.
after 6 seconds?
After
Like what happened to deceleration after 6?
it start
Is it increasing or decreasing?
decreasing. It start decreasing.
The deceleration, look,
Yeah, it start
this part,
It is increasing.
deceleration refers to the slope. This part, it was steeper.
constant deceleration.
Yeah, it was constant. But after 6, what happened to the deceleration?
Decreasing.
It is decreasing
Yeah, that's
because the angle is decreasing. When the angle, like here, it is steeper, then the angle is decreasing. So at this point, the deceleration was maximum. At this point, the deceleration is 0. So what happened to the deceleration? after 6 seconds, it start to decrease. If a deceleration is decreasing, what happened to the force?
First,
Force and acceleration and force and deceleration are directly proportional. So the force will also decrease. So whenever acceleration increase, the force will also increase. If acceleration decrease, the force will also. If acceleration is 0, the force will be 0. So the question was, what happened to the size of the deceleration or the amount of deceleration after 6 seconds? So here we will write
second, the deceleration starts to decrease.
decrease. And what happened to the resultant force? That also decrease.
Decrease. 1 mark, 1 mark.
We don't have to explain a reason for that. As it's a 1 mark, the decrease will score the mark. If it was 2 mark, then we will explain with the reason.
Oh, we didn't know.